Hi everyone. Today David and I will discuss a topic that constantly confuses AP Physics 1 students, Atwood machines. An Atwood machine is a basic physics laboratory device often used to demonstrate basic principles of dynamics and acceleration. The machine typically involves a pulley, a string, and a system of masses. Keys to solving Atwood machine problems are recognizing that the force transmitted by a string or rope, known as tension, is constant throughout the string, and choosing a consistent direction as positive.
Atwood machines are typically prevalent in introductory physics courses. They are used to learn about Newton's first law. When seen this way, it essentially states that an object's velocity will not change unless the forces on it are unbalanced. So if the object is stationary, likewise right here, the forces are balanced because the same masses are causing it to remain stationary. Likewise, if an object had velocity going, like, let's say right here, everything is going to move at a constant velocity because the forces are balanced.
Now, if the forces are unbalanced, then the velocity of the objects will change. That is, the objects will have an acceleration. This is the basis for Newton's second law, which is force equals mass times acceleration. Newton's second law deals with the relationship between cause and effect, or what causes an object to change its motion. Since objects will continue moving in the same manner, something has to cause an object to change its velocity. This cause is always a force or a combination of forces. This imbalance is called the net force, or the vector sum of all applicable forces. Another factor in Newton's second law involves the role of mass. The three factors, force, acceleration, and mass, can then be used to describe the motion of an object that experiences an unbalanced force. Quantitatively, Newton's second law predicts that when there is an unbalanced force on an object or system, the resulting acceleration will be directly proportional to the net force, while inversely proportional to the object or system's mass.
Newton's third law of motion deals with how two objects interact with each other via forces. When two objects share a force, they're often called what is an action-reaction force pair. For an example, an object will interact with a second object, and the second object with an equal amount of force will interact but in the opposite direction. In this example, I am standing on the floor. I am also putting a force on the floor. The floor is going to react by placing the exact amount of force on me. That way, I'm not going through the floor. The key for using Newton's third law is to identify the two objects, then look for how they interact with each other.
So here we have a problem. We have two masses, M1, M2, where M1 is greater than M2, and the pulley and string are both massless and frictionless. Okay, David, I'd like to see you solve this.
Alrighty, so I'm going to first do a free body diagram. So is the tension the same?
Yes, David, you're absolutely correct. The tensions are equal. However, it is only in this specific situation where the string is massless and frictionless and the pulley is massless. Therefore, the pulley has no moment of inertia and the tensions are equal.
Alright, so first we want to solve for tension. To do that, we take the mass of block 1 times the gravity. Then you subtract that by the tension to get the mass times the acceleration, mass 1. Then you also have the tension from this one. You're going to subtract it from the mass of the second block times gravity. That's going to equal the mass of the second block times acceleration. Now we can solve for tension. Tension will equal the mass of the second block times g plus the mass of the second block times a, which is acceleration. Cut me off. Okay, now that I have tension, What am I supposed to do now?
This is what you do, David. So, you've got your force equations. For your two blocks. And you have just solved for tension by rearranging your variables. Now plug this back into this equation and you'll get and we're looking to solve for the acceleration. So rearrange your variables. And that's it.